Uh, that means we will continue today to study polar coordinate system and how it is defined some curves and the relation between the Cartesian coordinate system and polar coordinate systems. The polar coordinate system also used for many purposes because sometimes much easier to present the curve by in the polar coordinate system than in Cartesian coordinate system. Look here. I will plot some graph which is defined in polar coordinate system. You know, again, let us say initially I will remind. That means here the origin. Here there is a zero ray, which is also possible to write that x. And the position of any particles, that means the p, defined by two numbers. That means the r and theta. That means the r, it is a distance from origin to positions p, and this should be angle theta. That means from here we see that in this case, if you have some graph of some line, in this case, that means we define it r should be a function of the theta. That means I will write, instead of r here, I will write this is f theta. F theta. That means there should be a function f theta. This is also possible continuous function, or maybe piecewise functions, and so on. That means that this is a relation. That means the distance depends on the angle. Here I will present some curves in the polar graphs for functions. That means you see that as I will take the theta equal to theta naught should be constant. That means the angle is not changed. What will be graph on this case? That means the graph on this case should be like this. Let us say some angle. That means this will be like this straight line. Here's the angle theta. You know, in this case, in the Cartesian coordinate system or rectangular coordinate system, this will be y equal to some ax. That means here's a kx, should be equal to tangent of this angle. Other possibility, that means r equal, here's the sum a divided to cos theta, which is equal a to sec theta. That means that this, from here you see, that means r times cos theta equal to a. That means from here I will see r cos theta should be a, which is a constant. That means when increased angle, that means the cos may be changed from 0 up to pi by 2. In this case, this product should be always constant, because therefore this line should be the following. That means here you will find, that means we will take theta equal to 0. If the angle equal to 0, that means r will be equal to a. That means for 0, that means when we will take the 0 angle, that means this will be a. Here, a. But when it is, because you know, when we increase the theta, cos decreasing, therefore r should be increased. And if you plot the graph will be this. This is graph for this function. R equal to a second theta. Other graphs which is possible to present that means let us I will take the r equal to 1. That means the r equal to 1, it is that means the distance to the point of the curve always equal to 1. That if we plot this graph, that means here's a 1, here's a minus 1, here's a 1, here's a minus 1. That means we receive like this circle. This is a circle. That means this is r equal to 1. If we take the other r, if I will take the r cos theta, r equal to a cos theta, in this case, this will be also the circle, but the radius of the circle will be equal to equal to a by 2 radius, and center of this will be in the x axis in distance a by 2. That means that if I will plot this graph, that means that here's a by 2, and this here distance also a by 2. That means that we have such circle, this circle. And at last, if they will take the r equal to a sine theta, also cycle, which is should be like this. That means that here the distance, here the center will be in y-axis, that means in vertical line, and it is also touch the x-axis and have like this. Radius also a by 2. So we so sometimes it is very easier to present by this way. Let us now we define what the relation between the, that means the sum, I told the previous class, I told that sometimes presented that when r will be negative. That means let us, I will take the following positions of the particles, which is defined by these coordinates. That means I will take the point P, have following coordinates. That means r equal to 2, angle equal to pi by 6. That means if for angle you add 2 pi, it will be the same point, because you see, because it will be full rotations about the origin. That means so that means that this is possible to write. This will be pi. Here's a 2. Here's a pi by 6. Here possible to revolve. That means revolve in the counterclockwise direction, which we decide the positive, or clockwise direction, which will be negative. Therefore, if you take the any time, therefore if you take minus 2 pi n, it is defined the same point. But sometimes this is possible to write that this is a point defined by following coordinates. That means minus 2, and here that means pi by 6, possible to add or subtract, that means minus pi. That means this is should be by this coordinate. That means this is should be equal pi minus 2. Here will be minus 5 by 6 pi. That means it is, I told the previous time, I will not in the future apply the negative value for radius, because radius is the distance as usually. But you must know that if this is also sometimes used. And here also possible here why it is, you see, before it is angle will be pi by 2 when r is a positive. That means the position is the following. That means here, if you take the distance here as a 2, that means pi by 6, it is 30 degrees. That means this point. That means the p equal to 2 pi by 6, or possible to define that by other these quantities. But if you take the r minus, that means you will take in this direction. That means that opposite. That means you decided that r is the opposite, that it will be symmetric placed respect to the origin. That means approximately here, right? That means there will be this should be what should be this is a position will be equal to minus, possible to write that it will be pi. Let us I will write the q, not pi, q. Here will be minus 2 because angle here is pi by 6 by 6. But if I would like to have the same, that means it is necessary to rotate on this direction. That means add pi or subtract pi. It is the same, give us the same position. Therefore, this that possible to write here the pi point should be has the same position. That means a minus 2. Here, if I will subtract, that means there will be minus. Let us here the minus 5 by 6 pi, and so on. That means it's possible now to add. There is therefore there is examples 11.1 where you will compare. Let us I will for this I will consider such questions. This question we considered during the interactive session. Now I will not would like to continue consideration. Relation between the polar coordinates and rectangular coordinates, that means Cartesian coordinates. It is very easy to define the coordinates. That means let us I will take this. That means the x. If we again we plot the graph, this is Cartesian coordinate x and y axis. Here this is the angle theta, radius r. You see here the x should be this one. That means the x should be equal to r cos theta, y equal to this one, all this the same. That means the y equal to r sine theta. So if the given this point r and theta, possible to transfer by these relations to x, y. Possible to make opposite. That means if the given the x, that means if the given x and y, how to find on the in this case polar coordinates. polar coordinate, that means the r you see. That means the r should be under root x squared y squared. That means the r should be equal to r squared, x squared plus y squared. Well, what should be here's a theta. Theta should be equal to arctangent y divided to x. Y divided to x. That means it's possible to define this coordinate. Here we, for example, I will plot some graph. Here coordinates, polar coordinate, here's a Cartesian coordinate. That means here given r cos theta. You see, r cos theta. That means therefore this will be x. That means r cos theta equal to x. That means r square cos theta and sine theta. Let us here is equal to 2. That means x equal to 2. That means r square cos theta to sine theta. R cos theta equal to 4. That means that this is equal to 4. That means xy plus here the r cos theta give us x, r sine theta will give us y. That means xy equal to 4. That means this will be following graph. That means y divided to 4 by x. That means it define a hyperbola. And last this one, 1 minus cos theta, r equal to 1 minus cos theta. That means if I will simplify this, that means I will take here again to find the x, it is necessary from this relation to multiply to cos theta, to receive the y, multiply to this. After that they exclude, you receive in this case. You see, this is the same as the presentation in the parametric representation. Therefore, to get relation between the sine and cos, I omit this one. That means I will find the x. That means I will find the x. Let us here. I will write. That means the x should be equal to 1 minus cos theta times cos theta. Y will be equal to 1 minus cos theta times sine theta. And this is, you see, I received parametric representations. Therefore, if I exclude x and y, I receive the following equations. That means x4 plus y4 plus here 2x square y square square plus 2x cubed plus 2xy square plus and minus y4 y square minus y square equal to 0. You see, here it is more simple view, but here very long. But it is we had these presentations. Okay, that means we again with some example we consider some later. That means how possible to graphing this what the polar coordinate. That means first of all that means it is necessary to check the symmetry of the given functions. That means respect to coordinates. And also it is necessary to calculate the derivatives. Let us now, that means if this is graph and defined by polar coordinate, but it is a plot on the Cartesian coordinate system, therefore how to find the some slope of this graph? You know, let us I remind you how we define when we have the graph of the function in x, y plane. That means this is a function sum, this one, and here I would like to find the x naught. It is what will be tangent of the slope. Slope will be this. It is attached here in this like this. This is will be a graph which is defined the slope. Or here the angle theta. Theta. That means possible. That means that y prime in the point x naught will be equal to dy to dx derivative and the point x naught, or this is should be equal tan, here's the tan angle of this one. That means also because the graph, that means a tangent defined by this equation. That means you know, that means because this is a straight line, y minus y naught should be equal to here the y prime in the point x naught. Here the y naught, it might be the point, this same point or any other point, but derivative must calculate it only in this point also, or also possible to calculate in any other point of this one. But because the function this is defined y, therefore it is necessary to calculate the derivative only where is this tangent line touch with this curve. That means this will be equal to x minus x naught. That means this graph. How that means it is we defined it in Cartesian coordinate system. How to find in the if the function given in like this. That means r should be equal to f theta. How to find this now the slope for this case? For this case, I make the following because you know, that means if I will find x will be equal to r times cos theta. That means that this will be f theta cos theta. Y should be equal to r sine theta equal to f theta to sine theta. Okay, that means I remind you, when we have the polar parametric representation of function, that means x should be a function of t, and y also will be a function of t. But here the parameter is a theta. Therefore, that means that dy to dx possible to define as a dy to d theta divided dx to d theta. Let us to calculate. Let us calculate this derivative and this derivative. That means the derivative from this function and these functions. Let us initially, I will find the y to d theta. dy to d theta, it is this one. That means it is necessary to take derivative from the products of the f theta and sine theta. That means it is a product of two functions. That means the first will be equal to f prime theta multiply to sine theta and plus f theta to sine theta. Okay, let us now, I will take other case. That means dx to d theta should be equal to, again, I will take derivative from this. That means f theta prime theta cos theta minus f theta to sine theta. So, taking the ratio of this, I will get following result. That means dy to d theta, or to dx, sorry, dx should be equal this ratio of this function to this function. That means that f prime theta to sine theta plus f theta to cos cos theta, right? Cos theta. That means here's a f prime theta, here's a cos theta minus f theta to sine theta. That means this is should be the slope. That means you see it is not the same like when you find the derivative from this function. That means r equal to f theta. You find the r to d theta, which will be f prime theta. When it is coincide, that means this is not that you see derivative of, if you take from these functions derivative, that means define the derivative coincide, but the slope define it by this formula, because you know slope always it is a ratio that dy to dx, So when that means, but I told that when you consider derivatives in Cartesian coordinate system, that means dx to the dy to dx in the some point x naught should be equal to some tangent theta naught. That means let us see when it is considered by this ratio, should be by this results coincide by this case. That means this coincides this one. This is possible only in the case when the distance, that means if the graph of which is presented by the polar functions, that means f theta r, that means r equal to f theta. That means that this is should be equal to 0. That means this equal to 0. That means that when the curve, which is plotted in the polar coordinates, it is a path from origin. That means from this point. That means, for example, you have, for example, this curve, like this, and it is passed from this, like this. You have such like this in the polar coordinate. That means only in this case that this angle should be theta, and this, because you see it is passed from origin, therefore here there will be 0, this will be 0, f prime cancel, sine to cos, you exactly, that means if f theta equal to 0, that means r equal to 0, that means the curve passed from origin, and in this case dy slope coincide in this point. Let us, I will take the some point r naught. That means in 0 here's some angle theta exactly will be equal to tan theta naught. Only in the case when it is passed from origin. Well, how to plot the graphs? How to plot the graph? Here I prepared one example. I special calculated, and I would like to make how possible to calculate. That means here it is as usually possible also to guess, and also necessary to know some property of the functions, which as we sketch the graph for when in the Cartesian coordinate system. For this case also it is necessary to know symmetry of the graph and other some properties of the graph possible to calculate. Let us given the following function. 2 here 1 minus cos theta. Cos theta. Let us, I will plot the graph of these functions. That means I make the following table. Here I will write the value of r, which is I receive. That means this will be r. Here's a theta. I take the following theta. That means here's a 0. That means pi by 6. And here's pi by 3. Then pi by 3. Pi by 2. Pi by 2. Then 2 pi by 3 and 5 pi by 6. That means all this angle less than pi, and at last pi. And calculate the value, or according to the equation, when it is a cos equal to 0. That means here I receive result. You see, when I will take the 0, cos theta equal to 1, therefore 1 minus 1, 0. That means here's a 0. For this angle, that means the cos pi 6 equal under root 3 divided by 2, and after simplification of calculation you receive following result. That means approximately 0.268 for this. And pi by 3. pi by 3, 1 by 2. That means the 1 by 2, 1 minus 1 by 2, and multiply 2 will be 1. That means this will be 1. Then pi by 2. Pi by 2 it is 0. That means here will be 2. In this case will be 3. For this case will be 3.73. And here will be equal to 4. Because you see that it is the distance. That means this will be 1. Here's a minus 1. That means minus will be 1. 2 multiplied to 2, 4. That means we have these points. Now, I would like to plot this graph. Okay, that means when angle, that means this is a 0 ray direction. That means the angle. I will take in this direction. That means from 0 up to 2 pi. That look here. That means you see, if this is also x coordinate. That means if you take theta to minus theta, r will be the same. That means there is a symmetry. Therefore, enough only in this part to construct some graph. Other will be symmetric respect to this axis. That means here the point. That means the maximum point 4. That means 4. Here's the 1, 2, 3. Here's the 4. Okay, that means 0, this point, then angle equal to pi by 3. That means approximately this angle. That means here the value will be about 0.3, approximately here. Like this. Then pi by 3. Pi by 3 will be 1. For this angle will be 1. Then pi by 2 will be 2. That means here, this angle. That means it is should be here, this angle. You see, this angle. And then it is continue to increase. Then when will be 2 pi by 3, that means a pi by 3 added to this 90 degrees, that means approximately should be 3. That means approximately should be here. Then at last here's pi by 6, that means approximately will be here. That means here distance, that means this is distance, should be, oh sorry, here's wrong. That means not here. The distance will be, it is next to see to distance. That means here's 2. That means here minus 1, minus 2, minus 3, minus 3, and minus 4. Minus 4. That means here well distance will be this. That means increase it, and then it is the opposite. That means should be like this graph. If you plot, that means other part will be symmetric. It is not so symmetric. Let us make the more symmetric. it is like this. This is called cardioid graph. It is, you see, is like heart. Therefore, it is called the cardioid graph. This function. Well, other graph also you will find in the, you can read in the book, because I have no time for discussion. Other graph, because it is, let us we consider the other possibilities, how possible to calculate some area under polar graph. Again, let us initially, I will remind you how we will find the graph of the, which is concluded between two radius, which is divided by some angle. That means that you see, I have this r, and this is distance the same. Here's the arc. Angle, if the angle will be enough small, that means that if the angle will be, this angle will be small, that means delta t. That means that if, because if angle will be small, here's the r and here's the r. Right? This is possible, this arc should be equal approximately to this one. That means this to segment. So this is, I receive this triangle where two sides the same. That means it is necessary to calculate this approximately. If you connect this one, also will be approximate r. So therefore, for the delta A should be equal to 1 by 2 r square delta t. Delta t is this one. That means delta r under this. That means this sector. That area of this sector equal to 1 by 2 r square delta t. That means if we have some arbitrary polar curve, here's the origin. Here's, I will take the coordinate system. Here's the x, here's the y, and here's I will take some curve which is defined by, that means the r should be equal to f theta, this curve r theta, and I would like to find what will be, and this is I will take some initial angle, this is angle alpha, this angle I will take the beta. That means how we can find, again we make the same as divide for many sectors, which is that means the arc, which arc will be enough small. That means like this. Oh no, this part is not included because I would like to integrate to find this part only. That means that I made like this, like this, like this, and so on. That means that should be a lot. That means that in this case, total area approximately possible to decide. That means there will be equal to first area of the first sector. That means 1 by 2 r1 delta square delta t1 plus 1 by 2 r2 square delta t2 square plus 1 by 2 r3 square delta t3, and so on. That means if I will write the limits, that means this is will be Riemann sum, That means the A possible to write as the limit delta t go to 0, number of the sector go to infinity, and here will be sum from k up 1 to n. Here will be 1 by 2 r k square delta k square delta k. Oh. Delta theta k delta k this one. That means that this limit, because this is a limit of Riemann sum, that means it will be integral from alpha to beta 1 by 2. Here will be f theta, because the function r defined this one, f theta square and d theta. So I receive the answer. That means the area which is enclosed by these sectors equal 1 by 2 integrals from alpha to beta f theta square d theta. So we receive this result for this. Let us we consider some example. This is also, if you would like, because to write the r, it is possible to write 1 by 2. Here's 1 by 2 integral from alpha to beta. Here will be r square, which is a function of the theta, the theta. That means the area enclosed inside of this sector. How to define when we area restricted by some two curves? That means I will consider the case when R1 which is larger than 0 and less, here's R which is smaller than R2, here's that means it is necessary to find where crossing to the two curves which is defined by these equations. That means that these equations R, it is between them, but you see, should be this relation between this one, the first curve, this is the second curve, and in this case the area, like in the when we calculated using yx functions, this will be 1 by 2. Here should be integral from alpha to beta. Here the R1 R2 theta square minus R1 square theta and d theta. That means when we have in this case the graph which is enclosed on when we have the region restricted by two functions, R1, R2 theta, which is larger than R1. You see, R2 larger than 1. R, it is a variable which is changed. That means in this case will be like this. One example. Let us, I will consider, calculate the graph of following functions. I will plot the graph of the following function and calculate the area. That r equal to 1 plus cos theta. This is also cardioid graph, but this will be like this. Before I fold like this, now this will be this graph. It is enough to calculate in this part, possible to, of course, from 0. That means that here the theta changed from 0 up to 2 pi. That means it is necessary to find the area. Of course, area should be equal to from 0 to pi. Possible, again, I will tell you that possible to calculate the area which is here and then double it. But possible directly to calculate this integral will be 1 by 2 r squared d theta. So I plot here 1 by 2. Here the integral from 0 to pi. Here 2 will be 4 square 4 1 plus cos theta square 1 plus cos d theta. So 4, that means there will be 2 integrals. That means I will take I make the following. 1 by cos theta. In the book given one of the possibilities to calculation. I will use the following formula because you know cos theta divided by 2 equal 1 plus cos theta divided by 2. Possible to use. In the book, here the second square of this sum. I will use this formula. Therefore, here you see square 4. 4 cancelled. Therefore, because I will take that this will be equal to 2 cos, therefore will be 16, sorry, that means the 16 by 2. Here will be integral from 0 to pi. Here will be cos square 1 by 2 theta d theta. That means this formula. That means now you will find yourself these integrals. And answer should be the following, 6 pi, if you calculate this integral. For today, finish. Okay, see you tomorrow. Oh, sorry. Yes, okay. Cos theta. Sorry, this is not necessary to improve. Here will be cos theta. Here will be 2. That means 2 theta. Cos squared 2 theta.
Fine, thank you.